Now, as you see here, we can see, as we recall from the first slide or the previous slides, that we have different standard deviations, curves, different values. As you see from this curve, we have a different, if we have a different values of the mean, as you see here, and imagine with me that we have the x-axis and the y-axis. Mu here is, the mu is just only and mu2 and mu3. As you see, the width of this curves is totally different from each other, and also the means. You can see that. Now, as you see here, that we have mu2. Remember that mu2 is higher than mu1, but lower than mu3. It means that we are dealing with three different means. The first mean is lower than mu2, mu1 is lower than mu2, and mu2 is lower than mu3. So the mean will be shifted to the right. Okay, the graph will be shifted on the x-axis, while different values of sigma standard deviation determines the degree of flatness or peakness of the graph. Now, the mean, if we observe any curve that shifted to the right in the y-axis, in x-axis, it means there is differences between the means of two populations, for example. Okay, but the peakness now, or the flatness or the peakness, okay, of the curve is determined by what? By the standard deviation. So the standard deviation gives us the peakness or the flatness of this curve, and also the mean. The different means give us the shifting from shifting on the x-axis. If we have three different means, for example, you can draw for them three different curves. But the peak or the flatness of this curve, okay, depends on what? On the standard deviation. The standard deviation, again, it can be calculated by the square root of the variance. The variance equation, remember that, is equal to summation of xi minus x bar square over n minus 1 if we are dealing with samples. Okay, sampling, not a whole population. If we are dealing with a population, it means that sigma equal to summation of xi minus x bar square over n. Okay, so this is how can we deal with the normal distribution curve. We are dealing with such different values of the mean and also of the standard deviation. And remember that the mean of the standard normal curve is equal to 0, standard deviation equal to 1. Okay, and below the area, all the area will equal to 1. Okay. Now we have two populations, as you see here. One of them, it is the height in inches actually. Example, normal curve, the height of males and females. Okay, we can see the men, as you see here, the men mean equal to 69. With sigma equal to 2.8. Okay, this is the height of the male. But if you go to the women, you can see that the mu equal to 63.6, sigma 2.5. If we draw the curve, the normal distribution curve, we would to see the shape of this normal distribution curve. You can see the mean. Okay, for the men, and also as you see, the mean here is 69 for the men, which is shifted to the right in the x-axis. Okay, and also you can see the mean for the women. But the flatness or peakness of this curve is affected by what? By the sigma. You can see sigma for the mean or the peak of the women is totally 2.5, but 2.8 for the men. So this is how can we deal, and how can the mu or the mean and sigma or standard deviation affected the shape of the standard or the standard normal distribution curve, the normal distribution curve in general. So this is how can we differentiate between the different shapes of the normal distribution curve. We have a standard scores. You can see this formula, the standard scores, the formula for covering any value x to the z-scores. Now remember with me, now I want to give you all to know that we have standard normal tables. We have a z tables and t tables. Now we can take a z-score from the table, okay, by using the equation, the value z equal to value minus the mean over standard deviation. It means x minus mu over sigma. This is how can we use the standard scores. How can we convert it to the z-scores? How can we convert the values of x, okay, in the standard normal curve? If we have, for example, any certain value and we have its mean and the standard deviation for it, we can convert it to the z-scores. Z-scores. So z-scores measures the number of standard deviations that a value falls from the mean. Now you have the definition of the z-score. The z-score measures the number of standard deviations, that a value falls from the mean. Okay? How this is, what do you mean by the z values? Now, once the mean, mu, and standard deviation have been specified, finding probabilities is a simple process for a normal variable. So if we specify the mean or mu, standard deviation or sigma, if we are dealing with the whole population, or we draw a sample from this population and I give you the differences between mu and x bar, for example, and standard deviation and sigma. How can we, when we can use sigma and when we can use the mu? So if we specify those values, the two values, whether it is standard deviation sigma or mu, or standard deviation sampling standard deviation or sample mean, okay, the process will be very easy. It will be very simple. Now the first one, to convert the endpoints of an interval of interest to z-scores. We do need to convert the endpoints to z-scores. We do need to look to the probabilities associated with this, with the z-scores. Okay, with the z-scores, we do need first to convert them on an interval of interest of z values or z scores, and look to the probabilities associated with these